So in our previous class, we have discussed about different type of stresses which is occurred in the rigid pavement, and among these two type of stresses are there: temperature stress and warping stress. So there are different locations, critical locations where these stresses will be imposed, and there are combination of stresses in different time of the season and during the different time variation in a single day. For example, in the summer season midday, the critical stress for the east region is given by that one, that is your stress at the edge, stress at the corner minus frictional stress. So similarly, this combination of the stresses are given for different seasons and for different time duration in a given day. Now after that, this up to that portion we have discussed. So after that, there are other type of things which we need to know about the rigid pavement. Now in the rigid pavement, joints are very important. Okay, so in the rigid pavement, these joints helps to relieve the temperature stresses, and therefore this joint should be made very carefully. Okay, now there are two types of joint in the rigid pavement. One is expansion joint and another one is contraction joint. So the purpose of the expansion joint is to allow the expansion of the pavement due to rising temperature with respect to construction temperature. So basically what happens whenever in the temperature rises, the rigid pavement tends to increase in its size. Okay, now if there is no joint, in that case, because of this rising temperature, the length will be increased, and that increase of the length would be get affected or would be get opposed by the rigidity of the pavement if there is no joint. So in such cases, stresses would be huge. Okay, therefore, in the rigid pavement, you need to provide some joints where that stresses can be relieved by allowing the expansion of the rigid pavement. Now, this uh, expansion joint are generally provide along the longitudinal direction. Design involves finding the joint spacing for given expansion joint thickness, say 2.5 centimeter. It is specified by the IRC, and it is subjected to some maximum spacing, say 140 as per IRC. Okay, so these are the some basic specifications of the expansion joint. Okay, so see, these are the expansion joints. So sometimes in the expansion joint, some filler material is uh, attached with it. Okay, why filler material is attached with it or filled with it? So that the continuity of the rigid pavement is there. Okay, so that vehicle comfort can be maintained over there. So therefore, in some cases, you have to use the filler material for the expansion joints. Now another type of joint is there, that is called contraction joint. Now the purpose of the contraction joint is to allow the contraction of the slab due to falling slab temperature below the construction temperature. Now beside the expansion joint, some contraction joint is also there, and it is also placed in the longitudinal directions, and these joints helps to contract the slab if the slab temperature falls because of the environmental action. Now the design consideration are the movement is restricted by the subgrade friction, because under the rigid pavement there will be subgrade and it will resist the movement or restrict the movement, and therefore frictional stresses will be generated Design involves the length of the slab given by, that is the length of the slab as per the contraction joint is considered, where your SC is allowable stress in tension in cement concrete and is taken as 0.8 kg per centimeter square, and W is the unit weight of the concrete, which can be taken as 2400 kg per centimeter cube, and F is the coefficient of friction between the interface between the slab and your soil subgrade, and it is taken as 1.5. Steel reinforcement can be used in the contraction joint, however, with a maximum spacing of 4.5 meter as per the IRC is considered. Okay, so this is the contraction joint. Now see, the width of the construction joint would be lesser than the expansion joint. Now in the expansion joint or in the contraction joint or in the longitudinal joint or transverse joint, some of the bars are used. Okay, steel bars are used. So basically there are two types of bars are used. One is dowel bar and another one is tie bar. Now, generally, dowel bars are used in the transverse direction, and it helps to transfer the load or transfer some of the stresses from one slab to another slab. So it would be like that. Suppose this is the slab and these are different joints of the slab. So your dowel bars are used along this transverse direction. These are the dowel bars. Now the purpose of the dowel bars is to transfer the stresses from one slab to another. Now another type of bar is used, that is called tie bars, which is provided in the longitudinal direction. Generally tie bars do not transfer the load, but it helps to keep the slab in a same place, or it helps to make the rigidity of the slab as a constant. So the design considerations of the dowel bars are generally mild steel rounded bars are used and bonded on one side and free on another side. So how it would be? So it would be like that. Suppose this is a slab and this is another slab. Now if you provide your dowel bar, one end should be free and another end should be fixed, okay, so that the slab can easily move in between this due to the expansion of the slab. So what are the design procedures for the dowel bars? So first one is you have to find out the length of the dowel bars using this formula. And step 2, find the load transfer capacities PS, PF and PP of single dowel bar with the LD, that is the length. And step 3, assume load capacity of the dowel bar is 40% of the wheel load. Whatever wheel load is there, you have to assume that 40% of the wheel load should be taken by the dowel bars. And step 4, you have to consider about the spacing of the dowel bar. Then another type of bars, as we have discussed, is tie bars. So in contrast to dowel bars, tie bars are not load transfer device. They do not transfer the load but serve as a mean to tie two slabs. If there are two adjacent slabs, then tie bar helps to tie them. As the name suggests, it ties two slabs. Hence, the tie bars must be deformed or hooked and must be firmly anchored in the concrete to function properly. So, in case of dowel bars, one end should be free and one end should be fixed. But in case of tie bars, two ends should be fixed very properly. They are smaller than the dowel bars and placed at a large intervals. They are provided across longitudinal joint. So, as we have discussed, if it is one slab and if it is another slab and this is the longitudinal joint, so they are provided in this direction, the longitudinal direction, or in the longitudinal joints, they are used to tie these two slabs or tie these two adjacent slabs. So there are different design consideration. First one is diameter and spacing. The diameter and the spacing is first found out by equating the total separate friction with the total tensile stress for a unit length. Hence the area of the steel per 1 meter centimeter square is given by here your AS into SP equal to B into H, breadth into height into unit weight of the slab into coefficient of the friction. Where B is the width of the pavement panel in meter, H is the depth of the pavement in centimeter, W is the unit weight of the concrete assumed as per IRC, that is 2400 kg per centimeter square. F is the coefficient of friction and it is assumed as 1.5, and SS is the allowable working tensile stress in steel and it is assumed as 1750 kg per centimeter square and assume 0.8 to 1.5 centimeter diameter of tie bars for the design. So these are the design considerations. Now step 2 is length of the tie bar. Length of the tie bar is twice the length needed to develop bond stress equal to working tensile stress and is given by LT equal to P into SS divided by 2 SP, where SS is the allowable tensile stress in kg per centimeter square and SP is the allowable bond stress and can be assumed for plain deformed bars respectively as 17.5 and 24.6 kg per centimeter square as per the IRC. So this SS value, LP value, you all get this value from the IRC 58 code. Okay, so from these two steps, you can easily find out. From the first one, you have to find out what is the area of the bars required, and from the second formula, you will get an idea about the length of the tie bar used. So this is some numericals that design of dowel bars and tie bars. So you just go to these questions and try to solve this numerical using the formula provided in the design step. Okay, by using this step, you can easily find out what is the length of the or design of the dowel bars and tie bars. You just try to complete these numericals and let me know if you face any difficulties regarding this. Now another important thing is your pavement failures. Okay, so you have designed your pavement. After some time, the pavement tends to fail because of different conditions. So what are these conditions and how the pavement could be fail? Okay, so there are different theories, there are different failure patterns for the pavement. So for the flexible pavement, we assume that wheel load is transferred by grain to grain from one layer to another layer. Therefore, you need to place the superior layer over the top surface and inferior layer in the bottom one. So, and the wheel load is assumed to transfer at an angle of 45 5D. And from this concept, equivalent single wheel load concept has been arrived. So, generally, the pavements are designed in such a way so that it can withstand a total load repetitions of 1 million cycles of the load repetitions. So generally, whatever load has been applied to the pavement by the wheel load, if we consider only the load, in that case, that load may be minimal. But what happens because of the repetitive applications of the cyclic load that becomes very much impactful and which causes pavement deformations. So this failure of the pavement mainly attributes to inadequate stability of the substrate, excessive applications of the stress, okay, and this excessive applications of the stress happens due to the overloading conditions of the vehicles. Therefore, in different stakeholders, generally weight of the loaded vehicles has been checked to know whether they are overloading or not. So if they are overloading, in that case, stress induced by the vehicles could be very much high, which would cause pavement deformation. And another one is plastic deformation. So basically, there are two types of deformations: plastic deformations and elastic deformations. So in the elastic deformations, whatever deformation has occurred, that deformation will got recovered whenever you uh, reduce the load or when you remove the load. But for the plastic deformation, that deformation is permanent and you cannot revert back to your original positions. Then failure in subbase or base course due to inadequate stability. Suppose your base course or subbase course, whatever aggregate you have chosen, that are not stabilized enough, okay, or improper grading has been used. For that reason, the pavement may fail. Loss of binding action. Suppose what you have used elongated aggregate or flaky aggregate or rounded type of aggregate. In that case, the aggregate cannot bond together properly. Interlocking properties of the aggregate cannot be formed over there, and therefore loss of binding action would happen. Loss of bearing force materials. What happens due to the repetitive applications of the load, and if the aggregates are of inferior quality, in that case what happens, the aggregate got damaged and it make into dust particles, and therefore the load carrying capacity of the base and subbase course will be drastically reduced, and inadequate wiring force. Suppose over the top portion, that is over the binding course, you have provided a wiring force and that wiring force is not adequate enough. So if it is not adequate, in that case the load transferred to the base and subbase would be of high magnitude, and therefore it will cause the failure of the pavement. And there are different type of failures, and causes of permanent premature failures are rotting due to high variation in ambient temperatures and uncontrolled heavy axle loads, limitation of pavement design procedure to meet local environmental conditions. Suppose you have designed a flexible pavement without considering the local conditions. Okay, local conditions means suppose you know that the thickness of the base or surface force should be 200 mm. So suppose you have provided that 200 mm without thinking about the quality of the locally available aggregate over there. Or suppose there are some site conditions like low groundwater levels or some distortion to the surface drainage conditions or some cross drainage work. So for that reason also subgrade may damaged, and which will impacted the upper layers of the flexible pavement. Now if we discuss about the common flexible pavement failure type, there are different type of failures like cracking, deformation, deterioration, mat problems, and problems associated with the seal growth. Now there are different types of flexible pavement failures. So first one is longitudinal cracking. So as the name suggests, this type of cracking, this is the longitudinal cracking. This type of cracking would be appear in the longitudinal direction along the length of the road. Okay, so this is a longitudinal cracking. So another type of cracking is fatigue cracking. So fatigue cracking cracks in asphalt layer that are caused by repeated traffic loading. Now the cracks indicate fatigue failure of the asphalt layer. So when the cracking is more than 20% of the total surface area of the flexible pavement, in that case we can tell that the flexible pavement has failed. So this is a fatigue failure. Okay, this is a fatigue failure. This type of failures of the pavement is fatigue failure. So when this type of failure reach up to 20% of the total pavement width or length which we have considered, in that case we can say that pavement has failed. So another type of failure is transverse cracking. So as the name suggests, this transverse cracking would be appeared in the transverse direction of the pavement. So this is the transverse cracking. So all this type of cracking occurs due to the excessive repetitions of the load, and for that some tensile stresses would be generated just above the base course and beneath the your uh, binder course, and because of the tensile stress this type of pavement failure would occur. Then another type of cracking is reflection cracking. So in the reflection cracking it would appear that it is reflected. Suppose this is the cracking, reflection cracking, and another reflection cracking would be there. So these two type of cracking would be similar in length and diameter. This type of cracking is called reflection cracking. So another type of cracking is block cracking. In that case, cracking would be generated as a block pattern. Okay, so pattern of cracks that divide the pavement into approximately rectangular pieces. Rectangular block range in size from approximately 0.1 square yard to 12 square yards. So these are the block cracking. Then each cracking occurs due to the inadequate formulations of the each region. Okay, now Carson shaped cracks or this type of cracks would be generated along the edge of the flexible pavement and are located within 2 feet of the pavement edge, adjacent to the unpaved shoulder. It includes longitudinal cracks outside of the wheel path and within 2 feet of the pavement edge. Okay, so this type of failure along the longitudinal direction and in the each portion of the pavement is called edge cracking. Then another failure comes that is called rutting. Rutting occurs due to the compressive stress which would be in the subgrade layer. Okay, so rutting generally it a longitudinal surface depression that develops in the wheel path of flexible pavement under traffic. This rutting is associated with the compressive stress and that is a permanent failure. Excessive rutting condition may lead to potholes and other type of permanent failures. So this is basically rutting failure, and see it always occurs along the wheel path. So along the wheel path, when the stresses are imposed because of the compressive stress, that subgrade got deflected, and because of this rutting failure generally occurs. So another type of failure is corrugation. So corrugation means this type of failure would be like that along the transverse direction, like a corrugation. Okay, this type of failure is called corrugation failures. This type of failure is also occurred due to the compressive load or compressive stress. Then shoving means, suppose see this portion, the pavement portions over a top surface is displaced. Okay, so this action or this type of failures occurs due to the inadequate use of the grade, poorly graded bituminous material. Suppose in the hot region you are using a 30 to 40 grade bitumen. So in the summer season, that bitumen got very much softens and it will displace because of the action of the wheel. Okay, it is generally caused by braking or accelerating of the vehicles and is usually located on the hills or curves or at intersection. It also may have vertical displacement. So this type of failure is called shoving failure. Another failure is called depression. Depression, as the name suggests, some portion of the pavement could be depressed. Okay, it got lower elevations than the remaining portions of the pavement. It got depressed. This type of failure is called depression failure. So what are the steps associated with the surface maintenance of the highway? So in that case, these questions you have to prepare by yourself. There is an assignment you can do, how you treat the surface so that all type of these failures can be averted. What are the fatigue and rutting? Fatigue and rutting is discussed over there. What is fatigue failure and what is rutting failure, that is discussed in this portion, so you just have to look for it. And what are the function of highway treatment, why highway treatment is necessary? Highway treatment is necessary to avert all these types of failures occurred in the flexible pavement. So till now we have discussed about the flexible pavement failures. Now let us discuss about the failure in the rigid pavement. So there are different type of rigid pavement failures. So first one is overlay bumps. So this type of failures is called overlay bumps, as in the picture is given. In newly overlaid pavements, bumps occur where cracks in old pavements were recently filled. This problem is most prevalent on the thin overlays. What happens? Suppose there are already existing pavement layer. Above this, you are creating another pavement layer of the rigid pavement, and in the previous layer there are some cracks or there are some potholes which you have filled. So if the overlay over the old layer is thin, in that case that portion, okay, that portion, that is the affected portion which you have sealed, that portion will be appeared in the new pavement as a bump. See, it is as a bump. Okay, so this type of failure is called overlay bumps. Then another type of failure, it is called delamination. This is because of the loss of a large area of pavement surface. See, a large area of the pavement surface is lost. This is called delamination. Usually there is clear separation of the pavement surface from the layer below. Slippage cracking may often occur as a result of poor bonding or adhesion between layers. So therefore, tack coat and prime coat are generally used on top. between the adjacent layer so that the bond between different layers could be strong. Then potholes. These are the potholes. These are vowel-shaped holes of various size in the pavement surface, and minimum plane dimension is 150 mm. These potholes may appear in the flexible pavement also, and this type of potholes are caused because of the excessive rutting conditions, and they are considered as the failure due to the subgrade failure. Then patching. Patching is portion of the pavement surface greater than 0.1 square meter that has been removed and replaced or additional material applied to the pavement after original construction. Suppose after the original construction you have done some repairing work, and because of the repairing work some of the portions of the flexible pavement or rigid pavement got displaced, or you fill some other material, and for that there would be some patching. So this is called patching, or some bandage type. This is called patching. Then revealing. This is the revealing. This generally occurs in the flexible pavement, and this is occurred due to the washing out of the top layer. Okay, top layer of prime coat or tack coat. So wearing away of the pavement surface in high quality hot mix asphalt concrete that may be caused by the dislodging of aggregate particles and loss of asphalt binder. So if the quality of the asphalt binder or quantity of the asphalt binder is very much minimum, in that case, the aggregate portions in the binder material would be get exposed in the top surface. This type of is called revealing. Then stripping. Stripping is the loss of adhesive bond between the asphalt cement and the aggregate. Okay, so this is the stripping. Stripping means, suppose this is the bitumen. Bitumen is mixed with the aggregate. Now see this particle here. There is no bitumen particle around. So basically, it got separated from the bituminous material, and this type of failure is called stripping. Then polished aggregate, that is surface binder on a way to expose coarse aggregate. Okay, so in that case what happens, this is similar to your revealing. So for the excessive revealing, what happens, this top portion got easily washed out and the bottom portion got revealed, and after that this top surfacing got smoother because of the action of the repetitive wheel load. Another type of failure is called pumping. This is seeping or ejection of water and fines from beneath the pavement through cracks. Suppose there are some cracks, and from the cracks some binding materials and some finer materials will be get out from that crack. Okay, that is called pumping. As in your concrete technology there are one failure like pumping, so in this case also there are failures, it is called pumping failure. Then segregation, that is the separations of the coarse aggregate from the fine aggregate as a result of mishandling the mix. This segregation may happen in the rigid pavement as well as in the flexible pavement. So this is a example of the segregation failure. Then checking, these are the short transverse cracks, usually 1 to 3 inch in length and 1 to 3 inch apart, which occur in the surface of the hot mix asphalt mat at some time during the compaction process. Okay, this is called your checking. This type of failure is called checking. Then bleeding or flushing. So excessive bituminous binder occurring on the pavement surface may create a shiny glass-like reflective surface. So if you use excessive binder material, suppose you think that if we use the excessive material, in that case it would be good, but it would be worse because of the applications of the excessive material. The portions of the pavement can reflect some of the light directed towards it, and which will create some glare, and it will adversely affect the driving condition. So this type of condition is called bleeding or flushing. Then rock loss. In the rock loss, what happens? There are top surface, that is the wiring cores, and wiring cores are generally, or binder cores are generally made up of your bitumen and your coarse aggregate. So in the rock loss, what happens? There would be binder material, but aggregate would be lost from there, and some this type of structure would be formed. So this type of failure is called rock loss. Then bleeding for the fat spots. So excessive binder occurring on the surface treated pavement may create a shiny glass-like reflective appearance. Fat spots are localized bleeding. Okay, suppose in the localized area, that is for a small portions of the area. See, suppose this type of spot may appear where light can get reflected. This is called fat spot. Now, general surface maintenance. This is the general surface maintenance for that questions. So, for maintenance of gravel roads, blading and occasional resurfacing is required. So, if there is only gravel road, in that case, you have to maintain that road by occasionally resurfacing of the road. So why resurfacing is there? Because as the road is made up of only gravel, that gravel particle got distorted over a time because of the wind actions or because of the applied load over there. Therefore, you need to maintain that road. For surface treatments of low-tide bituminous surface in maintenance of the roads, patching, seal coating, or possible loosening, oiling, remixing, and relaying are involved. Suppose there are some bituminous roads, so occasionally you have to do for the patching. Suppose some particle got washed out or some potholes may occur. So in that potholes, you have to recover that potholes by filling that potholes with suitable material and make it as the same elevated elevation as of the existing pavement. For high-type bituminous concrete and Portland cement concrete, the removal and replacement of failure areas and resurfacing are approximate treatment method for highway maintenance. So for the high-type bituminous means that high-quality bituminous concrete road and Portland cement concrete road, that is for the rigid pavement, the affected area. Suppose you have encountered that in some area that failure occurred is maximum. So in such cases, you have to remove all the materials and remold that portion. Use same material and methods for road surface maintenance as far as possible. So suppose for some area you have used this type of techniques or this type of materials, for another area you have used another material and another method. This is not allowed. You have to be homogeneous in your work, in the material selection and in the process of your working. Highway maintenance must be planned for rapid performance and to cause least possible disruption or hazard to the traffic. So you have to maintain or maintenance work of the road portion or road surface when there would be less number of traffic, so as to cause less discomfort to the passengers or to the traffic. Now, surface treatment of the highways. There are different type of surface treatment. So first one is single surface treatment. Surface treatment means you have to treat the wiring course. So is wiring course in which the bituminous material is spread and the aggregate is placed uniformly over the applied bituminous mineral. The thickness of such layer approximately the nominal size of the aggregate used. So whatever material you have used in the surface course, here the thickness of the wiring course must be the thickness of the binder material you have used beneath that layer. Multiple surface treatment is a wiring surface in which a coarse aggregate is placed on bituminous coat which is already applied. That is, over the prime coat, you will apply another bituminous coat, followed by spraying of bitumen and then by subsequent application of final final aggregate over a second bitumen coat. So there would be prime coat, over that you will place some bituminous coat, over that you will spray some finer materials, over that you will place another layer of the bituminous coat. Generally, the minimum size of the smallest aggregate is one of the aggregate used in the preceding application using the thickness of single layer approximately maximum size of the aggregate. So the thickness of each layer should be the maximum size of the aggregate beneath that layer. Now, function of surface treatment. So what is the function of the surface treatment? The functions are to provide long-lasting economical surface for granular base road having light and medium traffic volume, to prevent entry of surface water into the old pavement that has been weathered or cracked. It improves the skid resistance of the bituminous surface where the surface is polished under traffic, to provide temporary cover in case of delayed incomplete pavement. So these are the some function of the surface treatment. That is why surface treatment is necessary. So in highway maintenance for good surface treatment, it is necessary that base course is well prepared to its profile and is made more free from potholes and ruts. So if there are already ruts and potholes, so before the surface treatment, you have to fill up that potholes and ruts, and after that you can construct the wiring course or new course. Excellence of surface dressing depends upon the correct proportion of binder aggregate. So optimum bitumen content you have to find out through simultaneous tests, and from that on you can say that this is the optimum bitumen content which can be used for the surface dressing. Before laying that first surface dressing coat, the base should be made free from all dust and loose soil. So occasionally you have seen that whenever surface dressing has been done, that is pavement maintenance has been done, the top portions of the pavement is cleaned using some broom and other machineries to make it clean, so that over it another type of layers could be formed. So if there are enough dust and other particles, in that case proper bonding would not be there between the old layer and the new one. In all bituminous construction, it is necessary that the newly surface poses a bond with the existing base at the interface, and for that in some cases prime coat or tack coats are used to make that proper bonding. So this is all about today's class. You can leave the meeting. Okay, I have noted down the attendance. You can leave the meeting.